Railways and climate change. I'm going to talk about railways and climate change. That photograph there is taken in 2007 when we had the floods in the Cotswolds and the Midlands and the north of the country. And just featuring at the bottom right there, do you remember Addlestrop? This was taken at Addlestrop on the Oxford-Worcester line, where we had something that was calculated as a 250-year return period storm on the 20th of July. And after the water subsided, the track was left hanging, which happened in many places. Addlestrop, there's a poem called Do You Remember Addlestrop by somebody called Edward Thomas. It's a fun poem if you want to look it up. I'll try and talk about, and I'll try and keep to time, weather, climate change, what are they? What do we know about climate change and why is it relevant to us as railway engineers and what we're doing about it? It's important as well that it's been picked up time and time again. Drainage is part of a system, a complex system. And I'll quickly mention some other climate change impacts of interest. It's not just about flooding and drainage. I'll look at flooding, I'll look at drainage in the main. I think it's important that we keep focused on that. But climate change and weather, two different things. Weather is like this chart here. I don't know if you can make out the British Isles there in yellow. But weather is what we experience now, it's today. That's what weather is. Climate change is sort of much larger aerial impacts, and this is one of the Met Office maps showing, I can't remember what it shows and I can't even read it either. I think it's annual average rainfall over a 30-year period. Climate's all about 30 years, long time periods. It's not what happens today. It's gradual change in climate over time that causes some funny things to happen with extreme weather. These diagrams and some more information can be found through the fact sheet link there from the Met Office. And I must say I'm indebted to the Met Office, RSSB and Network Rail for being able to use their material in this presentation. Weather and climate drivers. I won't go into this in too much detail, but you'll see a map of the globe there. The bottom left, you've got the major mechanisms called Hadley cells that make the weather different across the tropics, the subtropics and temperate parts and the northern parts of the hemispheres as we have here. The energy cycle with sun coming in, clouds blocking the sun. The water cycle, evaporation off the oceans, rainfall inland. And one thing changes everything, and that's man's impact. Greenhouse gases causing a heating up of the globe itself. Not by much, averages going up 1 or 2 degrees, but 2 degrees is quite an important figure for an average global temperature, because once you get above 2 degrees C rise over a baseline, which is way back in the 19th century, once you get over that 2 degrees C rise, you start to get things happening like major species extinction events, major droughts, major storms, etc., etc. And that's why in the autumn, in December, there's a big conference going on in Paris called COP15 rather, which is looking at global agreements on keeping greenhouse gas emissions down to reduce emissions and keep within the 2 degrees C rise over the next century. If you want to have more information, I would suggest you Google the Hadley Centre, the UK Climate Impacts Programme. I've written that out in full because we used to call it UKIP. And I've got some good friends that work for them now. They're based at Oxford University. Don't call us UKIP, they keep saying. And I also refer quite a bit here in this presentation, once or twice anyway, to the RSSB UIC Spark Rail website. I'll give a link to it here, and there's a screenshot of the climate change web pages. Tremendous resource. We've got 400 odd records on there about weather, climate and railways. Railway people can register quite easily. If you're not railway, you might have to provide some sort of proof of your interest in these areas, but it's fairly easy to register and get into that information. Why is it relevant? This chart here shows, and it's quite an old chart now, I think this was produced about 2006. It shows temperatures in the middle of Europe from 1900. The red line, the ziggy-zaggy red line, is a modelled temperature, and the black line that goes up to about 2005 is the actual. And what we're seeing there is remarkable correlation between the modelled and the actual temperatures. So it tells us our models are working. A couple of interesting things here. 2003 was a hot year. I remember blanket speed restrictions on Network Rail infrastructure that year because of heat, track buckle risk. That was a hot year. By the 2040s, that will be an average year. And by the 2060s, it will be a cool year. So there's some interesting things there why we should be interested. There's some other stuff in there about we're already committed to these rises up to the 2040s, 2050s by the emissions that have happened in the past. The atmosphere is full of inertia. It takes time for nature to scrub CO2 out of the atmosphere. If we turned off all greenhouse gas emissions today, we're still going to have temperatures rising up until the mid-2050s. So we need to prepare and adapt society, our railways, to what will be happening over the next 20, 30, 50 years. We think about asset life cycles, drainage, 60-year design life, bridges, 120-year design life. Stuff out there that was built in the 1850s. Didn't think about design-wise, but we keep them going. Andy just said refurbish, the stuff that's there. So long life cycles will be impacted. The railway is for moving people and goods around the country. And we'll be getting some changes in the future with that. We want to think about resilience and efficiency of doing things. One of the things about reducing greenhouse gas emissions is thinking about having better sustainable transport. And railways is part of that mix. Other changes, ageing population, demographics, migrants, all wanting to move. These are things that railways is good at, moving people and goods, efficient. These will mean that people will be more reliant on railways, I think, over the next 20, 30 years. And there's white papers at EU level saying modal shift. We want the railways to take twice as much as they do now, so the roads take less. These things mean we've got to think about the future climate for the railway. And again, Andy kind of hinted at this. What does drainage do? It's a system. So if you're prioritising drainage work, it's not a case that you might maintain a piece of drain because it's there, but what does that drain do? Track quality, yes. Off-track drainage might enhance or maintain the stability of earthworks. Other drainage might make sure line-side cabinets don't get flooded very frequently. So think about what it serves as a system. Kind of a history lesson, this bit. By the 1850s, most of the railway network in this country was laid down. And I put down as a coal and iron moving system. It was mostly for freight. And over the past 20, 30 years, as industries gone to the wayside, the freight railways turned into a passenger railway. And this is the kind of thing. I think this is one of the London Underground lines being built in the 1870s. And who said no standards? It was thrown up quickly. Nobody had standards to place material at such and such a depth and compact it in another layer and compact it in another layer. It was all thrown together. They cut through the landscape, so the railway is exposed to rainfall, high groundwater levels. Cowley Bridge Junction, year 2000, not 2012. It's happened there time and time again. I've got somewhere a colleague that has an engraving showing flooding at Cowley Bridge Junction in the 1850s. It's been a perennial, not perennial, but once every 10-year type problem down there. Landslips, not like the Canadian rock falls, but things have happened in Scotland with lots of heavy weather and lines being blocked. And the railway as a system today is much more vulnerable than it was, say, 50 years ago. Think about control systems. Nowadays it tends to be push a button and some electronics make things work, but we used to have these things. Waggle a lever and a wire moves and a signal moves and the train moves off. Telegraph wires were strung on poles. Nowadays, they're in troughs at the line side, which is your emergency drainage system, by the way. They're quite useful. Train wheel diameters, I think, were about 3 foot in diameter. They had white metal bearings, and they could actually go through water without damage. Roller bearings, if they get water into them, can be quite badly compromised. And electronics. One of my favourite pictures, Class 220 or 221 stuck on Dora's seawall in 2003. It was there for 3 hours for a number of things. One, at the time, the driver was only allowed to reboot the computer system 3 times before it went into shutdown mode. 2, salt water got into the electrical couplings along the unit, so that's why the computer failed. 3, the railway's a system, and in the old days, if we had a failure in Dora's seawall, we'd have brought out a locomotive from Exeter Depot and hooked on this thing called a chain, coupling hook, and hauled the thing away. The rescue locomotive for this thing was 3 hours away at Birmingham because the couplings aren't compatible. Systems are quite vulnerable. £103,000 that cost Network Rail and delay minute charges to Virgin Cross Country at the time. So things are more vulnerable now. We've got to care for these assets a bit more than we had to maybe 50 years ago. Things to remember. I heard this one, or something similar, from an earlier talk. Water is the civil engineer's greatest enemy. Thomas Telford is reputed to have said that. But I'd like to add one of mine. Some of you may have heard this. It tends to go downhill. I remember some colleagues in Western Region years ago trying to persuade me that water in Chipping Salisbury Tunnel went uphill. Well, hydraulic jumps maybe, but that's another thing. So what's the railways and industry doing about climate change? Well, there's this thing called T1009 that we've been calling Tracker, Tomorrow's Railway and Climate Change Adaptation. A report has just been published on Phase 1. It's available on the RSSB website, the SPARK website. It looks at the need to increase resilience of the GB railway in response to changes in climate. 2 phases. Phase 1 completed June, which is this one here, and I've got a picture of this as well in a minute, just in case you forget. This Phase 1 looked at knowledge, available knowledge around the world on climate change and railways and infrastructure generally, and looked at what gaps there were in the knowledge and things that we could do fairly swiftly to make things more resilient. So we looked at standards for weather risk management, we looked at research papers. There's 120 recommendations that we put into 10 themes. In many ways, this whole programme, Phase 1 and Phase 2, has come up with 200 odd recommendations, which is too much, and we're having to prioritise them and get some key messages out. Phase 1 as well is accessible through SPARK. I've said that. We found 470 documents that we put into SPARK that you can access. Phase 2 is taking things a bit further. I won't go into too much detail here, but it's looking at the vulnerabilities and it's looking at developing support tools for increasing resilience. And some of those tools are things like measuring railway resilience in a different way and using things different to delay minutes to try and categorise how resilient railway is. It's looking at the economics of climate change and how investment rules could be changed to help us invest to make things resilient over the longer term. It's looking at GIS risk tools as well. Some examples of climate change, I said I'd mention them fairly quickly. Temperatures relative to 1961 to 1990, increases in the summer averages by about 5 degrees across the UK in the 2080s. Now, an average increase is one thing, but the effect of that bell-shaped curve and average temperatures there on the extremes means your extremes are going to be quite a bit different and more extreme events of heat. Summer and winter precipitations, minus 40 in the summer, drier summers, hotter summers, plus 33% in rainfall in the winter. And there are regional variations as well. Sea level rise between 12 and 76 centimetres by 2095 around the country. Storm surges, the 50-year return period storm surge will be increasing by 0.8 of a millimetre per year in the Bristol Channel. And lightning days for all regions of the UK will increase. I won't dwell on these, but I'll kind of highlight a bit that you might find of interest. But what can we do about it? One of the practical tools, the NR Network Rail Drainage Manual, what I wrote, well, I did a bit of it. 2010 that was published. It's got some good hints, some good guidance in there. I'm bound to say that, aren't I? I think important things, coming back to Andy's presentation, it asks you to think of the drainage as a system. You don't just have to maintain one bit, you've got to think about it from outfall to source and maintain it from downstream to upstream, things like that. I think there's a couple of bits of guidance in there that I found quite useful, and I'd taken from other parts of the water flood management industry where I worked in the 1990s. One is, when you're designing drainage, think of what happens when it becomes blocked. So does that water overflow in a spot that you're not actually controlling the water and waterlog a cutting slope, as it happened in Gillingham, or is it Gillingham in Dorset, beside the tunnel about 5 or 6 years ago? The drainage was blocked. It was well maintained otherwise. The drainage was blocked, but the cutting slope became waterlogged and walloped onto the track, derailed the train. So think about what happens if the performance of the drainage is degraded. The other thing it asks you to do is think about what happens when the design capacity is exceeded. Because we're economic guys, we engineers, we'll design it for that size of pipe, and that's economic. You can't design for every eventuality, but you can think about what happens if the capacity is exceeded. There's guidance in the drainage manual for climate change as well. I mean, the drainage manual asks you to design the drain and add 20% for future climate change. And that sounds like a very much of a wet finger in the air, but that's based on planning guidance and EA guidance from about 6 or 7 years ago. And things have changed slightly, but the resources and SMARC I mentioned, and a couple of them are the appendices to the Phase 1 Tracker Programme, 2009 programme. And Appendix G1 and G2, these two documents, I quite like. One of them gives you a summary of information by climate variable, and another one by information by system or subsystem. So they're split up by sort of track, drainage, earthworks in one of them, and they're split up by weather variable in the other. And there's a couple of other appendices that give you tables like this. Extreme value analysis for rainfall return periods for 40 towns and cities in England and Wales. So England and Wales are covered, and it will give you, I can come across here and show, 2040s, 2080s, 2060s and 2080s, summertime and wintertime, 5 to 100 year return period rainfall events, and how they will change in those decades. So that can help you fine-tune drainage design. And another set of information we've picked up, and you can hardly read this one as well. Just checking to see what it says. These are changes in climate variables, so it's heat and rainfall projected across different parts of the country that we've picked up on the way through the research programme, the T1009 research programme. So I hope I'm giving you a hook there to look at some of this stuff online and gain more information if you need it. The next steps as I see them, I think, are to review the Network Rail standards. I won't be doing that, but somebody needs to run with that. It's a recommendation coming out of the climate change work. Review the Network Rail drainage standards in liaison with people at the Environment Agency who've done a heck of a lot of research into rainfall, flooding. Highways England, who would be using similar sort of standards. The railway streets ahead of everybody else in this area, looking at impacts on infrastructure, I must say. The Environment Agency have done a lot of work looking at future flood patterns, but linking it to infrastructure, the railway's really streets ahead. And another one I should have mentioned there is Ofwat, because the first chart I showed you a minute ago came from an Ofwat analysis to guide water companies. This will give consistency of approach across infrastructure sectors. So if somebody designs a drain on a highway that discharges on the railway, at least you'll know you're using the same kind of background tools. Of course, they're not necessarily doing that just now. I think it's assessing criticality of drainage systems against what they serve. So is it track quality, is it an earthwork, is it a control centre, a line-side cabinet? I think that's part of what the manual, the standard, the Network Rail standard asks you to do anyway, in terms of drainage management plans. But I've also given you a link here to a Syria report on flooding and resistance and resilience for critical infrastructure. And there's a link there to the web page. I think you might have to buy it off Syria, that's the only thing. But it's a report that looks at some of the flood events and problems that happened during the 2007 floods and what people have been doing about them. And it gives a clue in there as to how you can sort of say this is more critical than that. Some risk assessment tools in there for assessing criticality. Keep thinking system. What is connected to what? What are the interdependencies? drainage, track quality, overhead line registration, flooding, flood damage, all those things. And keep spending with this wonderful thing, this budget, this funding pot that Andy mentioned earlier on. I think they're the sorts of things that need to be going on with an eye to the future. Quickly, other climate change impacts of interest. High temperatures, rail buckling. Well, I'm bound to say that, aren't I? A track conference. This is a map produced in the T925 tracker program about 5 years ago that shows the impact of Network Rail's standard for track management. That says if the temperature is going to be above, is it 30, 31 degrees for the next 3 days, then don't disturb the ballast. This is a sort of 2040s view, showing that actually these colours, the dark red colours down here, the dark red colours suggest that by the 2040s you won't be able to touch the track for 2 months during the summer. So you need to think track standards and things like that. There's passenger and worker comfort as well with the heat, because the average will go up and the hotter days will be more frequent. Low temperatures, there will be fewer icy cold days, but we'll still get winters like we did in 2010, with hopefully Eurostars not going into the Channel Tunnel and ice melting and causing problems. I was lucky, I was on one that got out of the tunnel on that day, December the 16th or 17th, I think it was that year. My friends from Network Rail Operations Weather team were on the next one behind me from Brussels, an hour behind me. I got into St Pancras half an hour late at about 7 o'clock at night. They got into St Pancras at about 4 o'clock in the morning. Yeah, you still will get those kinds of events, snow and ice falls. High precipitation events we think are going to get more frequent. So things like I heard earlier, alarm systems, understanding how your earth works, how your track behaves, thresholds, they need to be looked at. Bridge scour, these things are going to be important. Sea levels, coastal erosion, damage to seawalls, earthwork failure, all these things are possible. High winds, damage to equipment and line-side fires. The science is pretty good in the top 4, not so good with high winds. Impacts and potential resilience measures. I'll just let you read these. I'm quite keen to point at the one on the bottom left. Coastal flooding, like Dorish, but don't forget Wales. Because I think Wales's population last year, Dorish had all the fanfare and the Orange Army, but I think it was another 8 to 10 weeks before the Cambrian coastline got reopened. And Wales, the Cumbrian coast, is parts of Scotland that are quite low down. All these are potential impacts from climate change. Potential resilience measures. For we engineers, these are fairly common sense. But when you speak to other groups who are not familiar with the topic, then they find some of these things surprising, but actually I think they're pretty common sense things to do. Catenary maintenance. Interesting one, desiccation of earthworks in Anglia a couple of years ago caused out of registration overhead line. We're going to get more of that. So these things are of interest. And that's it, thank you.